Good morning, students. Today we are going to discuss about the topic is mesh analysis. Mesh analysis, also known as a loop analysis, is a method for calculating currents in a planar circuit using Kirchhoff's voltage law. We well known the Kirchhoff's voltage law says that in a closed loop, the algebraic sum of potential rise is equal to the algebraic sum of potential drop. By using this Kirchhoff's voltage law, we can solve the mesh analysis. Okay, what are the steps are involved in a mesh analysis? First step, identifying the number of meshes in a circuit. The given circuit, given problem, how many meshes are present in that given problem. The first step is we can identify the meshes. Second step, assign the mesh currents. Sometimes given problem, the current direction also mentioned, otherwise we can assign the mesh currents. Next step, write the Kirchhoff's voltage law equation, KVL equation, from how many meshes are present in that given problem. We can assign the or write the KVL equation, then solve the currents and then calculate the values. Okay, next, this is the example problem. Find the loop currents for the given circuit by using mesh current method. Okay, in this problem the two meshes are given but not current direction get mentioned. Okay, from the first slide, the first step, identifying the mesh. We can identify the meshes and label the current. Here B1, R1, R2 and B1 is one closed loop. B2, R3, R2 and B2, it is a mesh 2. Okay, two loops are present in that given problem. So we can assign the current direction. The current only flowing in closed loop only. It is when the current is going to closed circuit, only the current is present. Otherwise, the current will be a 0. Open circuit, the current will be a 0. So here B1, R1, R2 and B1 is a closed loop. So the current, one current is flowing through first mesh, and then second current flowing through B2, R2, R3 and B2. So I1 and I2. So I1 current in a direction of clockwise direction. I2 is anti-clockwise direction. We can choose or consider the current direction by ohm. Even the two currents also taking the direction of clockwise direction or anti-clockwise direction. Here first loop we are taking I1 current in clockwise direction, I2 current in anti-clockwise direction. This is the first step. Second step, label the voltage drop polarities. The voltage drop polarity is nothing but the value of drops from 20 volt. So 28 volt voltage total rise. For first mesh, the total rise of the voltage is 28 volt. The potential drop is R1 drop and R2 drop. Here the voltage V equal to I into R drop. Okay. Next we can form the equation. First mesh we can form the equation V equal to I into R. Here the V is total potential rise is equal to 28 volt equal to potential drop in 4 ohm resistor. 4 ohm resistor I1 into 4 plus I2 resistor. The R2 resistor having two current flows, one is I1 current and then I2 current. So I1 plus I2, the direction of current is I1 current direction of upward to downward, and I2 current also upward to downward. The two current add in the 2 ohm resistor. So the equation get modified into I1 plus I2 into 2. Then we can simplify this equation. Finally we can get the first equation, 28 equal to 6I1 plus 2I2. Then for loop 2, we have the KVL equation is 7 equal to I2 I1 in plus I2 plus I1 into 2. We can simplify this equation. Finally we can get 7 equal to 2I1 plus 3I2. Next we can directly solve the equation. From the first equation, 28 equal to 6I1 plus 2I2, and 7 equal to 2i1 plus 3i2. We can solve this equation. We can eliminate i1. Now the second equation is multiple with minus 3. So finally we can get the equation is minus 21 equal to minus 6i1 minus 9i2. So plus 6i1 minus 6i1 get cancelled. The remaining value is 7 equal to minus 7i2. Now we can find the i2 current equal to minus 1. So similarly we can apply this i2 current in any one of the equation. We can get I1 current equal to 5 ampere. Finally we can redraw the mesh currents by determining the branches. Like this we can redraw the values. The I1 current value is 5 ampere and I2 current value is minus 1. Then finally we can get the current flowing through 2 ohm resistor is 4 ampere. 2 ohm resistor is 4 ampere because the I1 current is flowing from B1 source. The value is 5 ampere and B2 source value I2 current is minus 1. We can get final current flow through the 2 ohm resistor at the time of 2 sources present. 5 minus 1 equal to 4 ampere. Thank you.